As scientists and engineers, the way we understand the world around us is to design experiments and take measurements. The world's a complex place, however, and those complexities often conspire to make the measurement process somewhat problematic. Vibration, temperature, electrical interference can all have subtle influences on the measurements that we're taking. Our goal in this lecture is to study how computation can help us understand our experimental data and process it to help reveal the underlying truths.
As a first step in understanding experimental data, let's remind ourselves what we're about. So usually one of the first things we do is to develop an hypothesis of how things work. So this is a simple statement that says if I do X, Y will happen, or something equivalent to that. If we have a hypothesis, we'll quickly want to design an experiment and then take some measurements. And it's really these measurements that will tell us what the results of the experiment were. And in fact, we often will interchange the order of these two things. Sometimes we've done some experiments, and we're interested in making a hypothesis that explains the results. Other times we have a theory about how something works, and we're trying to design an experiment to prove the theory. In either case, once we have the measurements, then we're going to use computation to do several things. The first thing we're going to do is probably evaluate the hypothesis. What we'd like to do is determine if the measurements we made give us some evidence that, in fact, our hypothesis is true. The hypothesis may involve certain unknowns, some constants of proportionality, and one of the things we'd like to do with the measurements, if we decided that, in fact, the hypothesis is true, is determine the values of these unknowns in the hypothesis. And finally, and this is maybe one of the most important things that we're going to use computation for, is if we have a validated hypothesis, we would like to use it to predict consequences. And in fact, these may be consequences that would be very hard to do experimentally or very costly. So for example, if we've understood orbital mechanics, we may wish to use the computer to use the mathematical model of orbital mechanics to predict the trajectory we should take in order to successfully have a rover arrive at Mars.